Inverse functions and relations. So we're going to first take a look at inverse relations, and really an inverse relation is just the swapping of x and y coordinates. Now, we're going to discover a little bit later on that every function may have an inverse, but not every inverse is a function. But right now we're just looking at how we would map, let's say, if we had a relation, how we would map the inverse of that. And so here we're told that the ordered pairs of the relation, there's a relation that has ordered pairs -8, -3, -8, -6, and -3, -6. They're the coordinates of the vertices of a right triangle on the coordinate plane. Find the inverse of this relation and then describe the graph of the inverse. Well, let's start by just finding the inverse of the relation. So if I've got if the relation is has coordinates, let's say at -8, -3, well then I'm just going to swap the x's and y's, and so the inverse then would be -3, -8, and then it would be -6, -8. And then lastly, -6, -3. And that would represent the inverse of that relation. We just swapped x's and y's. Now we're going to jump over and we're going to actually graph this, and then we'll graph the inverse. And then we'll make some kind of description of the inverse. Hold on, it's coming at you now. Quick. Now, I had already graphed the relation. If you recall, the relation was -8, -3. That was one of the vertices. A second vertices was -8, -6. And then the third was -3, -6. And you can see that I have graphed it. It is, in fact, a right triangle. But now let's graph the inverse. So I'm going to go in here. Let's see, I want to make sure I'm doing a point. Okay, we're going to choose a point, and I'm going to call this first inverse of the -8, 3. Let's say I used ABC. I'm going to use DEF. So I'm going to go D equals. Well, the inverse then is -3, comma, -8. All right, there's that point. And then the inverse to point B, which was -8, -6. So I'm going to call that E equals -6, comma, -8, inverse of that. So there's point E. And then finally on point F is going to be the inverse of point C. Point C was -3, -6. So the inverse is going to be -6, comma, -3. All right. DEF. Let's see. We're going to see what that looks like. I'm going to put a segment in here. I'm going to go from D to E. And from E to F, and then back from F to D. All right, well, it's a right triangle as well. Now, I'm going to graph y equals x. I'm just going to hit in here, y equals x, and Shazam, it puts a line in there. And so, what kind of description do we have? Well, we have let's see, A is now going to map over here to D. And B is going to map to E, and C is going to map to F. So it's a reflection in the line y equals x. It is really kind of rotating, if you will. A goes to D, B goes to E, C goes to F. Z. Yeah, it's not just a simple, it's not just a simple rotation. It's actually a reflection. All right, well, Shazam.